Welcome back, minions, to Nick Does Some Mathematics. Here on a whiteboard with me, Nick, and some maths and a whiteboard and pens. Qu'est-ce que nous avons aujourd'hui? We are going to do a little bit of mechanics. What we have a center of mass question with a framework with 9 uniform rods. Let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9. Excellent. They make a bunch of right angle triangles, 3, 4, 5 triangles. That's cool. And our job is to find the distance of the center of mass from AC. But wait. They are all equal density or mass ratio, whatever you want to call it, apart from these 3. These are twice as dense, or whatever you want to call it. Okay, so they weigh twice as much per unit length as the other one, so we have to be quite careful about that. So probably the best way is to break this down into all the rods we have. So we've got AB, I've got BC, I've got AF in no particular order, I've got BF, I've got CF, I've got CD, I've got DF, I've got EF, and I've got ED. 1, 2, 3, 4, 5, 6, wicked. I got there without having a brain aneurysm. So let's have a look at mass, and let's call X their distance horizontally from AC. And we'll deal with part B in a sec. So, AB is length 3, essentially. It's all proportional, right? There's an A and a density coming up. And its distance from AC is actually 0, so that's quite nice. That one's 3, that one's 0. So, A to F, its length is 5. Now, because it's uniform, we know that its center of mass of this rod is halfway, which is going to be 2 away. Right, BF. Now, BF, its length is 4, but proportionally, its mass will be 8, because it's twice as dense. Now, how far away is it? It's 2. Well, 2A, right? We're going to put a bunch of A's in here. We'll put them back in at the end. 2A, 2A, there we go. Now, CF, same thing with CF. It is not, it might be length 5, but proportionally, it is contributing 10 to the length, to the mass. And its distance again there, it's halfway, so that will be 2A. CD is perfectly chill. That is a length of 4, and it's going to be 2A away in the middle. DF, again, instead of 3, it's contributing a 6. And that is 4A away. E to F is a length of 5, and that is going to be 4 plus another 2 is 6A away. And ED is length 4, and that is also 6A away. And through all of this, somewhere, there is my equivalent center of mass, all right, and that will be X bar away, okay? Right, what is the total of all this? 5 times 2A is 10A. 8 times 2A is 16A. 10 times 2A is 20A. 8A, 24A, 30A, 24A. Now, what's that equal to? That is the total turning effect of all of my rods. Well, that's got to be equivalent to the total turning effect times, that looks like a pi. We're going to call it X bar, fairly standard notation. Now, we've done mass proportional to the length. So what is the total length of all of this stuff? Well, it's all of that. 3, 6, 11, 19, 29, 33, 39, 48. I make that 48 X bar. All right. Let's put some of these down, because I've got big hands. They're not that big. 26, 46, 54, 74, 78, 108, 132. Right, both sides divisible by 4? I mean, definitely by 4, right? Because that will give me... Freeze frame, camera died. Let's pick up where we were. Was I on this side? Where was I in the continuity in this parallel universe? Right, let's just finish this one off. Yeah, they probably, yeah, 4. 4, 4. What, 4? 4. 4. 4. 4. 4. 4. 120. The difference divides by 4 because that is 120, which is 30, so that gives me 33. Oh no, I've divided by 3. Ridiculous man. So that would be 44. There we go, that's what I was dividing by 3. You know, this is what happens when you jump continuity, right? Yeah, divided by 4. So 11a over 4 is x bar. Okay, so where is that, give or take? Where is that, give or take? 11a over 4. So that is just under 3a. So it's going to be somewhere here. Right. Cool. Fine. Now, we're going to, let's say the total mass of our framework is capital M. We are going to hang a mass of, a particle mass km here at E. And we're going to spend everything from F. And when we do that, CE is going to remain horizontal. Let's find K. Okay. Let's find K. Now, a little picture here possibly will help. Now, let's take F. All right, let's take F is here. And the point is CE remains horizontal, right? CE remains horizontal. So that's E there, and that's C there. All right? Now, what have we figured out? We've figured out that essentially, now I don't know what the Y bar is, but I don't realistically care. So let's say it's somewhere there, and I've got mg acting there, and I know that that is 11a over 4. Now that does mean that I know that distance. That one there is 5a over 4. And at the same time, I'm going to hang a particle here, kmg, and that distance there is 4a. Now, if it hangs in equilibrium with this horizontal, these distances give me everything that I need. So let's take moments about F, which tells me that 4a times kmg is equal to, and that's why I wanted that one there, 5a over 4 times mg. I want a red pen. Things cancel, the A's cancel, the M's cancel, the G's cancel. All right. So we are left with 4k is 5 over 4, which tells me that k is 5 over 16. Simples. Nice. Even a horrible picture like this actually breaks down quite easily. And same here is finding, really you could get trapped in a loop here worrying about these distances for the diagonal parts, but just remember it's halfway, which means it's halfway horizontally and halfway vertically. NBD. Don't panic, chill, it's just mechanics. Don't forget to like, subscribe, hit the bell for notifications, drop us a comment to see how you're feeling about mechanics leading up into the tail end of this exam season. In the meantime, I am Nick. This was a cheeky bit of mechanics.